So, welcome to this webinar with Andrew IP from Australia on the other side of the world. My name is Holger Kast. I am the head of training education at TRI. We have a fantastic topic today, TRI Matrix and dental 3D printing, success through innovation. So I have the first part to talk about, and this is the matrix implant, and Andrew is talking with his really outstanding knowledge about 3D printing, the possibilities of 3D printing in implantology. He just told me yesterday that he had already more than 20 different printers. So we have really a great webinar ahead of us. There's some rules for the webinar. When you have questions, please write them in the question field here in the Zoom toolbar, and I will give these questions at the end of the show. We will pass the questions in our question and answer session at the end, or if there's an interesting question during the presentation, I even maybe talk to Andrew during his part. So before I give the word to Andrew, I would like to introduce you first of all to the TRI implant company. You can see here the Tobias Richter. Tobias Richter is the CEO and founder of TRI already more than 13 years ago. Our goal is it to provide 100% digital implant solutions for dentists and also for dental technicians. We are the #1 digital implant company. We are based in Switzerland. I am right now sitting in Zurich in the beautiful Switzerland, watching on the lake of Zurich. We are having our production site in Zurich, based in Zurich. So you are always welcome to give us a call, and we're going to show you our production site. We have since 13 years, since we are in the market with our performance line, high performance in implantology. I think from my point of view, because I'm also involved in a lot of developings at TRI, I'm a dental technician in the background, I think simplicity is one of the most goals of the TRI implant system. We are talking today about the matrix implant. The matrix implant has the big advantage that we eliminate the need of an abutment, and I will explain this in my part a little bit more detailed. So the simplicity is a big goal of all we do at TRI. But I think the main focus in our developing in our days is now the Think Digital. The Think Digital, this is why we are here together. Today we are talking about the digital way of implantology. So on the left side, you can see the evolution. That's what we do since more than 13 years at TRI. This is our performance line. So we started with a classical implant product, and this is the tissue level implant with a classical old-fashioned implant connection. It's an octagon connection, and also we have a bone level system with a hexagon connection, and this is all based on an analog workflow and based on prosthetics on top of abutments. And on the right side, you can see the revolution, the matrix implant line. This is all made also with a very big simplicity. All these implant lines, you can use the same surgical kit. So this gives also, again, this simplicity in the implant system. And on the right side, this is where we talk about today. This is the matrix implant system, no abutment, no cement, and no limitations, with a full digital workflow with included. So why we go into this full digital workflow with the matrix is shown a little bit on this picture. On the left side, you can see the conventional way. This is how every implant system works in our days. We have an implant, we have an abutment, and on top of this abutment, we connect this new world of digital workflows of CAD/CAM prosthetics. Either they are milled or also 3D printed. We need to connect these old connections, this old world of implant connection. We have to connect them with a tie base. On top, we can 3D print or mill a prosthetic on top of it. And on the right side, you can see already big advantages of the matrix implant system. We can go all the prosthetic way down into the tissue, in the connection of the implant, of the matrix implant, screw retain it without the need of an abutment, completely individually designed. Also, the emergence profile can be individually designed. to have a fully digital workflow created. So how is this possible? This is the matrix. You can see here, this is the matrix connection. This is, we can see here a nice, smoothly and smart designed connection with a very round interface going inside based on 3D printing and CAD/CAM milling technologies. In the back here, you have one rotational lock which peeks out a little bit into this connection. And this is just a picture where you can see a random milling tool, which any milling machine in this in the world has in the toolbox. And you can mill with these drills, you can mill this smoothly round connection in a high performance. And this is what we can mill. And also for 3D printing, where Andrew is going to take over later on. This is absolutely perfect to mill this connection as an STL file in a perfection into this inner connection. Just a few pictures for you how this milling can come out. This is a single crown based on an STL file. Everything we do in digital workflows is we have to design something, we create an STL file, and we have to add this on a milling machine in connection with the so-called TRI milling strategies. We are able to mill not just an STL file, as you can see it here. We mill with the perfect milling strategies, a perfect connection even before sintering. And due to sintering of the zirconia, we are able to reach an absolutely perfect connection, which you can screw retain with 35 newtons in zirconia here in the milled situation into this matrix connection. This is just another picture how single crowns can look like. And also we have a lot more possibilities in the full arch restorations. This is just a picture of a case which I will highly recommend to download later on. The QR code I'm going to share with you to our casebook, to all our studies we did at the end of my presentation. Please take out your phone and make sure that you download this QR code. This is a case done already more than 3 years ago. We have a 3 years follow-up, fully zirconia, no abutment involved, milled with a milling machine, which is certified on the TRI matrix milling. And this is only possible if you are certified, and then you are able to use this matrix implant system where you do not need an abutment anymore. Including in this matrix implant system, we included with every implant you buy from the from TRI, we included 8 different apps, 8 different apps which are included, and this is based on a completely digital workflow. You can see here 8 different apps, and I would like to talk about, this is the 4 apps I want to talk about before I pass the word to Andrew, because these apps are connected to 3D printing. So the Scan and Smile, for example, the Scan and Smile is a solution TRI is offering. And you have the possibility 24 hours a day from Monday to Friday to use our design service. And I think Andrew will show also some cases later on where he placed an implant, and then you send us the scan of this implant to position, and then later on only 20 minutes later, our design service makes sure that you get your design of your crown or even a 3-unit bridge in between 20 minutes. And this is what you can do on a 3D printer and 3D printed. And Andrew again will explain this much more detailed later on, how fast you can 3D print a temporary in an immediate workflow. How fast this can go, I show you in this video. So basically, you start with placing the implant, you add the scan body, then you do an intraoral scan, you send us this scan. We make sure that this design comes to you as an STL file. You put this STL file on your 3D printer and you are ready. So just again a little bit slower. You place an implant. You can see it here. There's not even done the bone grafting. You have this 3D touch scan body. You do the intraoral scan. You make sure that you send the scan to TRI, and we make sure that we send you a special 3D printing file for your 3D printer. This is the STL file with this special matrix connection, and then you can 3D print Even you can 3D print 5 times or 6 times this prosthetic, and not even 1 hour later, we are ready to place from 10 o'clock to 11 o'clock with implant placement. We make the patient happy in a chairside procedure. When you have an in-house 3D printer, this is possible only because we don't need an abutment. We don't need to add any cementation. We do not need a dental technician in this moment to make this work. So you are able to have in chairside prosthetic very quickly done. This is also possible for full arch restorations. All these full arch restorations are more in the QR code I'm going to share with you at the end. You can do a full arch upper and lower jaw, also 3D printed in 30 minutes, and you get the patient out with an upper and lower jaw chair side in 30 minutes. That's the first app I wanted to talk about. Also, what we offer you, I told you we do not have any abutments in the portfolio of the Matrix system, but what we offer, and also Andrew will go more into details of this, we have the so-called digital healing color library. This is basically an STL file. Again, it will be in the QR code I'm going to share with you at the end. This is an STL file with the Matrix connection. So you can use this STL file, 3D print for maybe material-wise for $1 or $2. You can 3D print these individual healing colors, and you can start manage your emergence profile from day one and have different shapes for different tooth forms. You see on the right side, there's molars. On the left side, there's more single crown shapes, and then you can 3D print it. You can just choose for your situation the right shape, and then you can screw retain this digital healing color in the patient's mouth, and you have a nice emergence profile within a very high aesthetic aspect. The next thing quickly, the scan bridge. The scan bridge is also an invention, for your fully digital workflow, especially in full arch restoration. What's the problem of intraoral scanning? We need reference points. So if you have especially a lower jaw in between those scan poils, you have no reference points, and there TRI offers you this so-called scan bridge. You see this is a scan bridge. You can click it to the scan body, and then you have even the beautiful design of the Swiss Matterhorn mountain. And this is we offer this as well for free. There's no cost for you. You can download this file. This is a file. You put it on your 3D printer. You print this out before you perform a full arch restoration, and then you are ready to click these designs to in between the long distance gaps, and then you have make sure that you have a perfect intraoral scan, which you can use for designing a full arch restoration and 3D print it in a very short time. This is the QR code I'm talking about. If you have a few seconds, just take your phone. This gives me the time to introduce you to Andrew. Andrew, I think it's time that you start your presentation. I'm really excited because I know we always include you, involve you in our developings, because you are really a master of 3D printing. You know so many things about 3D printing, and I'm really excited. Please start to share your screen and introduce yourself. I'm looking forward to your presentation. Thank you.
Cool. Thanks for that, Holger. Thanks for that introduction. Going to, I guess, the meat of the presentation today. Let's start my slideshow.
Super. Yeah, we already see your screen perfectly.
Fantastic.
Yes.
All right. Let's start. Yeah. So, g'day everyone. I know it's probably daytime where you are. Where I am, it's I think 10 past 10, so I should be in bed. But you know, I'm giving you guys a bit of a talk on 3D printing. So, I've been using the Matrix system for a couple of years now, and I really enjoy it. In case you want to contact me, my website's there. My socials are there as well, my Instagram, and any of the videos that I showed today, they will be on my YouTube channel as well. So yeah, feel free to subscribe to any of those channels if you want to follow and learn more. Right, so a little bit about me. I'm based in Sydney, Australia, probably very, very far away from most of you. And I'm a private general dentist. My list of credentials is all there. Done a lot of study, you know, in orthodontics, implantology, digital dentistry, but yeah, that's besides the point. I currently operate a number of 3D printers, about 4 of them actually. So currently. And I do happen to use a filament printer for my hobby stuff. And I also have access to a ceramic printer. In total, I've operated no less than 20 3D printers. So yeah, quite a lot. So yeah, I started 3D printing as a hobby at home. You can see these little models that I've got on the top right. That's basically what I started off 3D printing. Nothing to do with dentistry. Then, I started printing helmets for my cats, which Max and Minnie, which you can see on the right-hand side. So that helmet is printed on a sprint ray printer, and I spray painted that myself. And yeah, he no longer fits that helmet. He's pretty big now, but yeah, he's very, very tolerant. So yeah, I basically learned a lot of this myself through YouTube and Facebook. So very, not so peer-reviewed sources of education, but it is what it is. And now these days, most of my 3D printing is dental related. I actually do write 3D printer reviews. So if you know the Institute of Digital Dentistry, they're the guys who review intraoral scanners. And just this year, they released a big article on many of the 3D printers out there in the market for dentistry. There's about 14 printers there, and I wrote reviews on 9 of them because I've used so many. And yeah, if you want to check it out, just look up Institute of Digital Dentistry and it'll be on their blog. And just to prove a point, these are the 20 3D printers that I've used so far. So let's start off with a case, okay? What's actually possible currently? And this is a case using the matrix system, obviously. This particular patient, I promised them a fixed, restoration before they went on a cruise for a few months. And unfortunately, it was during COVID times, all those lockdowns. And I couldn't get the fixed restoration or the definitive restoration in time. So I had to, make good of my promise and had to give my patient some sort of fixed provisional restoration that would last, a number of months. And that's basically what I did in this particular case, all using 3D printing and different types of 3D printers. So in this case, I outsourced the design to a company called Hager's. So you can see the design is done on ExoCAD. It's a kind of like a half screw retained, half cemented provisional bridge, and there are some temporary abutments there. And what I'm actually going to do is I'm actually going to 3D print those temporary abutments in zirconia, and then I'm actually going to 3D print the bridge out of temporary resin. I use Flexera in this case. Here you can see the abutments being nested. You see that I've actually printed them twice. And the reason for that is whenever you start something, especially when you're new to the technology, the material cost of 3D printing is actually very, very low. So I printed a spare copy essentially, just in case I needed it. Turns out I didn't, but you never know when you need it, especially when you're polishing these things or you accidentally drop one, break one, lose one. It just saves you the time from repeating the whole 3D printing process again. And as I said, the material cost is really quite negligible. So yeah, this is basically ceramic printing in a nutshell. It's not so easy as resin 3D printing. It's very, very thick. You do need a very specific 3D printer, but I just wanted to show you guys a bit of zirconia printing because that's not often that you get the opportunity to see something like that. Okay, so we've got this temporary bridge and we're printing that out of Flexera Smile. Looks very good, and you can see it fully printed there. That's stained and characterized with OptiGlaze. And to be honest, I probably did a too good of a job characterizing this bridge. I know I did too good of a job because the patient hasn't come back for the definitive restoration. So these things can last. So when you are, making a temporary like this, the trick is not to make them look too good because they won't come back. But anyway, that's besides the point. And yeah, so I had this all done just in time for her cruise. And yeah, she hasn't come back yet for the definitive restoration. So I'm still waiting for the date that they'll break. But yeah, we shall see. I think we've got some photos of the appearance at insertion. Yeah, the abutments are a little bit visible, but I think the soft tissue would creep a little bit, especially when we're dealing with zirconia. Soft tissue tends to love zirconia. So that's the situation there. That's with the temporaries put in. So that's definitely good enough for a temporary solution. All right. So that's what's possible right now. And we'll go through a number of other cases as well. So why get into 3D printing? A lot of you don't have a 3D printer, or you're thinking about getting into it. It's really interesting. It's a really booming field right now. And there's a number of reasons why you should. First of all, you're cutting costs. To print a splint, it's much, much cheaper to print a splint compared to sending an impression to a lab, getting it made, then 2 weeks later you insert the splint. So first of all, you can cut costs to your practice. Second factor is that you're actually increasing the number of things that you can do. You're increasing productivity. You're increasing the number of services you can provide. Especially if you're doing the same day or same appointment dentistry. Especially some 3D printers, specifically Sprint Ray, fantastic options there for printable applications. You're saving time. I think I guess the most common example that I give is pouring up a model. When you pour up a model, you take an alginate. You have to get your nurse or your assistant to pour up the model, and that will take at least half an hour to 45 minutes to set. Take it out. It's messy. There's plaster everywhere. There's dust everywhere. Whereas 3D printing a model, you take an intraoral scan, 2 minutes. You can prepare it for free using software. And you can print both upper and lower models in the one hit in less than 30 minutes sometimes. No mess, very clean workflow, and there's no plaster. So yeah, huge time saving. And yeah, look, I entered 3D printing as a hobby. I think it's fun. And yeah, just because you have a 3D printer doesn't mean that you should just dedicate it just to dentistry. Use it for other things as well. So decisions. When we invest in any piece of hardware or technology, we need 3 criteria: desirability, feasibility, and profitability. Look, most of us are private practitioners. We have to be realistic. When we invest in something, we need to make sure that we're getting a bang for our buck. We're getting a worthwhile investment. So, first of all, is there a need or want to invest in this new technology? Do you really need it in your practice? Do you want it in your practice? Do you want to provide more services? Okay. Then you have to actually think of whether it's actually feasible, practical, realistic to introduce new technology into your practice. How big the learning curve is. Do you have space available? Do you have power, electricity available? Do you have the time to learn all of this? And finally, profitability. As I said, most of us here listening today, we're private practitioners. We have to, at the end of the day, make a living and earn a living, right? So we actually have to make some sort of profit whenever we invest in anything, right? Whether it's a mill, whether it's a 3D printer, whether it's an intraoral scanner. So you have to factor in, of course, your initial costs, because that's always going to be important. But don't forget the ongoing costs, your resins, your materials, your protective equipment, all of that stuff. And then also your time. Your time is important too. Us dentists, we bill the most when we're actually seeing patients, not really when we're printing things. So that also needs to be considered as well. So this is a table. I've roughly calculated what each of these dental applications costs, in euros. I think most of the attendees here are probably in Europe. But yeah, I'm not going to delve too much in this, but you can see that the material cost per printed application is really quite low. Okay, so you can take a screenshot, take a photo of this. If you don't, just let me know, and I can let you know the approximate estimates. So the fun stuff, what can we 3D print? Okay. First of all, we can print models, and models are so broad, models for, wax up models, clear aligner models that you can see on the top right-hand side. Lots of things that you can print when it comes to models. Models for mouth guards, retainers. It's a lot of applications. Then splints, okay? Very easy to do, very predictable, great materials out there. fantastic way to get your return on investment on a 3D printer. Surgical guides, we'll talk about them a bit later. Indirect bonding trays, then going clockwise, these printed restorations and dentures. So a lot of applications that we can 3D print. And so the big question, as I said, for many of you, you may not have a 3D printer. What should I get, right? Big question. And to be honest, you have to have the end goal in mind. Just like when we do implant dentistry, we have to think of, what's the end goal? What are we trying to do at the end? So we think of what we're going to do or what we want to achieve, and then we work backwards, right? How many users are going to use this 3D printer? The type of dental work. Are you just going to be printing models, or are you going to be printing a lot of things? Surgical guides, splints, models, of course, dentures, temporary or long-term provisional restorations. Then, if you've got so many different applications, you're probably going to want something a bit more robust. Don't just think that, I'm just going to print models for now and I'll see how I go. I always like to think, plan, what you may want to consider printing in the future, not just now, because otherwise you'll end up like myself and, own 20 printers, okay? Speed. Now, speed may not be important, but it's always important, to be honest, in my opinion. Speed is, we live in a society where patients expect, very rapid turnover, and we ourselves expect very rapid turnover, fast results, quick money, very, very fast. Everything's fast, faster in our society. So speed is always going to be important. Who's going to be doing the printing and post-processing? Are you delegating the task to people? If you are, then you're going to probably invest in a system that is a lot easier to use. And of course, when things go wrong, who's going to support you? Really important, because the worst, case scenario is that you buy the printer or you pay the money, and then when something happens, your sales rep magically disappears and you're someone else's problem. That's the worst case scenario. So what's available? A bit of science, but once again, I'm not going to delve too deeply in this. There's 3 major types of 3D printers available in dentistry. You've got your LCD printers, which are generally your cheaper printers. They basically have LEDs at the bottom of the printer, and they have an LCD panel that basically blocks off light. And all of these printers basically work on the premise that you have light curing your liquid resin in certain areas, layer by layer. So these partially cured layers are gradually built up to the application that you want to print. So that's your LCD printers. Your SLA printers would be like your Formlabs, very slow but very precise and accurate. You basically have a laser beam at the bottom of your tank, and then that is basically directed onto your resin. And it's very precise. It's really nice printing technology, but it's slow. And then finally, your gold standard would be your DLP printers, like your EnvisionTechs, your Seegers, your Sprint Rays. You have a projector that basically flashes lights all at once at the resin, selectively, of course. So it's very fast. If you're doing chairside or same-day applications, then basically DLP printers are your main option. And to be honest, all of these 3 options are great. You can't really go wrong with all of them. It just depends on what you want in a printer and what type of applications you want as well. Choose, as I said, work from the end and then work, backtrack, okay? You choose the printer based on what you want to print, the resins that you want to print, the applications that you want to print, the type of support, the reputability of the brand, and of course, the ease of use. You work backwards, right? Otherwise, you end up like this. Now, I started off with cheap 3D printers myself, as a hobbyist, and we all started off with LCD printers, and they're still fantastic. They're great units, especially if you want to start and get your toes wet a little bit. But support from the actual manufacturer is generally quite limited. You're generally relying on support from people on Facebook, or Facebook groups or your colleagues. There are quite a limited list of officially validated settings for dental specific resins. There are users who have created settings or worked out settings for these printers, which is fine, depending on your jurisdiction, how strict your country is with regards to regulation. And of course, the software used to manage these printers is not really specific for dental. So they can be a bit confusing, can be a bit daunting for the novice user. But they're cheap, very cheap. And then, of course, your more expensive setups. Here we got the Hager's chairside unit. DLP printers are in general, your more expensive setups. Generally, you're going to get better bang for your buck, better support from the manufacturer. You're going to get a list of officially validated resins, so you don't need to worry. As long as you follow the instructions for use, you're not going to be worried, oh, is something biocompatible or is it not? You don't need to worry about that. But of course, you pay extra, okay? And of course, you generally experience less hassles. But you also need to consider it's not just the printer itself. Printers, of course, get all the flash, they're flashy. Everyone focuses on the 3D printer, but you need your wash units, your curing units, really, really important. You need to get multiple containers for your wash units because you can't mix your biocompatible resins, like your surgical guide resin, your splint resin, with your non-biocompatible resins. That's generally your model resins. So it's like in Star Trek, you don't cross the streams, right? So you try not to mix washing these different types of resins together. Of course, curing units, very important. We are dealing with things that are going in the mouth, okay? So once things are going in the mouth for extended periods of time, we need validated workflows. We need to make sure that when we print something, it is fully pure, it is fully safe to be inserted in someone's mouth. I mean, imagine if it was your patient was your mum or your dad. Well, you would want whatever you're placing in their mouths to be perfectly safe. Also need to consider how easy it is to use. That includes your software, but also the physical workflow. How easy is it to train your staff to use your printer from start to finish, okay? And of course, as I've mentioned before, what do you want to print and how much space do you have? Sometimes you may not have space for multiple printers. You may only have space for one. Then you may want to spend a bit more on your printer because then you don't need to worrying about getting another printer in the future. So surgical guides and implant stuff. Now to the meat of the topic and why many of you have registered today. Surgical guides. I like to think of it as a bit like GPS for your implant placement. They come in sleeve or sleeveless options. Many options out there in terms of planning. I use Blue Sky Plan a lot, but I'm starting to use Exoplan quite a lot too. But yeah, for someone who's just starting out, Blue Sky Plan is fantastic. The Tri Matrix system has their library already preloaded onto it, so that's very, very good. You don't need to worry about measurements and things like that. And great resins out there. NextDent has a very tried and true surgical guide resin. Key Guide is pretty good. Sprint Ray has their own. Lots of great surgical guide resins out there. I autoclave mine, but I tend to use the low temperature cycle because for some surgical guide resins, they tend to crack if the temperature is a bit too high. There are users out there that cold stereo them, but I personally autoclave them properly. And why guided? Look, it's precise, it's accurate, especially for users who are not as used to implant surgery. It's a great tool. Now, would I rely on it? No, but it's a great tool to have, especially if you're planning it yourself. It's easy to plan it, especially with Blue Sky Plan. You'll see in a video in a sec. It's quite straightforward to plan. And then because you're planning it yourself, your cases back to front. You're more familiar with the cases, which is good. It's good for you as the operator. It's good for the patient because they're generally going to get a better outcome. So the workflow. First, of course, you need a cone beam and then an intraoral scan of the patient. Okay, you merge those two data sets together. Then you're going to design your surgical guide after planning the implant placement. We're going to print it, fully process it. We try it in. If we're happy, happy days. We're going to use that surgical guide to help prepare our osteotomy. So I'll go through this in a video later in this presentation. So temporaries, healing collars. As Holger mentioned, the Matrix has its own digital healing collar library. Fantastic. I basically print these healing collars out of crown or restorative resin. I did do a lot with zirconia, and I still do. The problem is that with zirconia, beautiful for the soft tissue, really, really beautiful, but you can't add to it, or it's very hard to grind it while the patient is in the chair. So these days, I actually do a lot of it with like crown resin, like Ceramco Crown Tech, because it's easy to remove, adjust, add if necessary. Okay. Of course, with the Matrix, they are designed or pre-designed already to be screwed directly onto the fixture. But if you're using an alternative, implant system, there are different options out there. I won't go through them today, but there are different options out there to design these printable healing collars. An example here, this is actually my aunt, and we had 2 implants placed. I printed these 2 healing collars out of Crown Tech and polished them with basically the Vita PMMA polishing burrs, just to a dullish shine. It shouldn't be too hard to polish, to be honest. And then I use a cotton buff or wheel to really, give these a really good shine. And I actually autoclave these. And I autoclave these because, these are going to be in an implant site. The resin itself will tolerate an autoclave cycle at least once, based on my own personal testing. Well, that's Crown Tech. I'm not sure about others. But yeah, I actually autoclave these. Okay. And of course, you can see on the right-hand side, that's after suture removal at 2 weeks. Right. So very easy to use. Fantastic. As I said, I printed them out in Crown Tech because just in case it's, the bite is a bit too much, I can quickly adjust it chair side. It's no big drama. And of course, if you want to do something even fancier, you can actually, plan or design your provisional implant crowns. This is a case where I'm planning in exoplan. This is a case, I think it's 1-5. So the tooth is still there. There is a vertical root fracture. And then I'm basically loading the files right now, and I'll merge the 2 data sets together. Yeah, so this is really nice case showing the whole workflow from start to finish, all the way from planning the implant surgery to designing the surgical guide, and then even designing a provisional implant crown based on this design. So of course, I can do this because I have access to exoplan and exocad. So here we go. So you can see that the tooth is still there, right? So we're going to later digitally remove that tooth. But first, yeah, we're just going to do our quick wax up on exocad. And then based off this wax up, we'll design our surgical guide. So everything's looking like it's merged quite well.
There's one question: why you have to create a wax up if you have
yeah, actually, to be honest, I could have skipped that part, but I was already recording, so I just put the tooth there. It doesn't really matter, to be honest. Like, you can skip that part completely. It's just, it automatically happens when you follow the workflow on exoplan. Yeah. But you don't need to. Yeah, because the tooth is already there. But yeah, here we're placing the implants. It's a 4.7 by 11.5 from my memory. Just checking, from all angles. And then approving the planning. Yeah. Okay, so now we're actually going to delete that tooth additionally. Like so. The good thing about exo plan is that you have these soft tissue options. You can remove as much or as little of the soft tissue as possible, which is what I've done in this case. Okay. And then we're basically going to mark our borders in a sec. Insertion direction. And yeah, marking our borders for the surgical guide. Very easy to do. Of course, you can do something similar in Blue Sky Plan, and I will actually show a case later with Blue Sky Plan. This is just one of the one of the planning options that you have available for Matrix users, where the Matrix system is already preloaded into the library of that software. Creating windows. So just to make sure that when I print it out and seed it, I can see that everything is fitting, passively and fitting well. And then of course you can manually adjust the surgical guide. Unfortunately, with PowerPoint, you can't speed up videos. So I just let this run through. And the great thing about ExoPlan and ExoCAD is that because the two software, there's a link between the two software options, you can actually design an immediately loaded temporary based off your plan, which is what I'm designing here. And you don't need a perfect design for this temporary, okay? Because number one is temporary. Number two, you can adjust the chair side, right? If you're printing out of Crown Tech or Bago or some sort of restorative resin, you can adjust them quite readily in the chair. So it doesn't need to be perfect. You can always add, remove, polish as necessary when the patient is there, once the implant's placed. So of course, it's not going to be perfect right now, but we will make changes accordingly based on the clinical situation. So once everything is merged, we'll basically, like so. As I said, it's not perfect, but it's enough for provisional. And we're just basically going to print that now. I think I'm going to print that on my SprintRay Pro 95S. First, that's the surgical guide. So for those who aren't familiar with 3D printers, we need to, each 3D printer will come with its own specific software. So this is SprintRay specific software because I'm using a SprintRay printer here. Think of it when you mill something, you need some software to nest the objects, to connect the digital file to the mill or printer in this case. All these little dots represent supports, which are like your little sprues that connect your object to the print platform. And I'm printing a couple here, right? As I said, you never know. If you drop it, break it, lose it, at least you have something a spare, right? And it costs next to nothing material-wise, but your time is expensive. Surgical guides being washed, very easy on the SprintRay system. Washed and dried. And then we're going to cure it in a validated cure unit, which is the ProCure 2. And yeah, 3 minutes later, our surgical guide is ready to be autoclaved. And then we're going to print our temporary restoration. Here, I'm going to be using Sprint Ray crown kit, actually, on the, I think it's the 55S, can't remember. So this is fantastic. Basically, it will print restorations really quickly, sometimes as low as 10 minutes if you have a small restoration. Here, it will take a bit longer. I think here's about 20 or 25 minutes. But yeah, great piece of kit for all Sprint Ray users. I highly recommend it if you really want to get serious about your restoration printing game. Printing a couple in case. All right. Whoop. Sorry, my screen's just died.
You can see my screen now. Yes,
Yeah, okay.
I think so. Okay,
Now
maybe that gives me just in between the time. Don't forget to ask your questions in the question field, in the Q&A field. I already answered some questions during your presentation, Andrew. We continue as soon your computer is continuing. Hopefully it will.
Yeah.
And here again, just for those who didn't see the introduction, here's the QR code for all detailed information about the matrix implant system. There's also detailed information about these 3D printing possibilities with the scan and smile solution. So there was, by the way, one question during your presentation regarding that the dental technician needs a high technical skills to work with those softwares. And I was answering this by, okay, if a dental technician already works digitally, it's a state of the art to design a crown on any tooth-based as a crown, or if it is based on an implant, that's not more or less a state-of-the-art procedure. And that's from that point of view, that's not a big education you need here. And those 3D printers, and this is what Andrew shows here, especially, for example, the Sprint Ray printer is a printer which you can use easily, and even your assistants in the clinic can adjust everything very easy. It just needs a small introduction by that printer supplier, or also TRI offers a screen sharing process. You can get a call or a video call from our technical support to get your machines running. How is it
Just
looking?
I just can't find the option to share my screen.
I can stop the option. I stop sharing my screen, and then you could share it again, I think. I just answered a question in this time from Nilovar.
Yeah.
Thank you for the question. Can we print only one model at a time? This depends on the size of your printer plate. So there's printers, and I think also when the technique allows us, Andrew is going to show us a technique where you can print very small crowns in a very small bath. And if you have a bigger printer plate, you can print as a laboratory. There's printers which can print 10 or 15 models in once. And there's printers which can print only one model, and this depends on the needs what you want. If you are, I don't know if this question is from a dental laboratory maybe, then I would recommend a bigger plate, because in a laboratory you want to print more models in once. If you use the matrix, you will see that the matrix doesn't need in the fully digital workflow models at all. Sometimes you do not even need to for single crowns in our you don't need to, in our opinion, you don't need to create a model at all. So as a dental technician, you would maybe have a bigger printer to print more models in once, and organize yourself that the printing is done over the night, and then the next day you have all your models printed. If you have a smaller need and want to print crowns, bridges, prostheses, especially like on the matrix system. So for example, you would have a smaller bath, and that also lowers your printing time, because if you talk about immediacy, you want to print faster, and therefore you need also a smaller plate maybe. Okay, Andrew, how's it looking? Can we try to get this run again?
Yeah, I'm trying to. Sorry about that, but yeah, my computer's going.
I might keep the audience here, and you get out.
Yeah, I might just
come in again.
Restart everything. Yeah, just bear with me for a sec. I do apologize.
Yeah. Stay there. I answer more questions. Please ask questions until Andrew is coming back. With regard to the curing unit, do we need dental specific ones? Curies plus all over. Yeah, that's a big part. What material you would use, what printer you would use is really, I mean, there are so many different printers in the market. There's printers which are not based on dental technician workflows. That's why you should always choose a printer which has the possibility to print in the material you want to use. So there's different suppliers and different materials which you can use. There's printers which can only print more or less in the model area and are not accurate enough to print also prosthetics. So one big point to choose a printer at first is how accurate it can print. For example, it might be necessary to print with 50 microns to really be accurate enough to screw retain, for example, a prosthetic directly into an implant. That should be a really accurate printing, better than 50 microns. And then so if you start thinking about buying a printer, you have to think about also see what type of materials can be printed with my printer. And for example, again, with Sprintwave, for example, they have a lot of range of different materials to print, either for guides, either for prosthetics and models, and there's different materials available, and this is really important. And then there's also what we have to say about materials. The materials are at the beginning of 3D printing, I would say. I mean, there's coming much more stable materials in the future, and from my side, from developing side, I would say like the 3D printing is overtaking the milling completely in the future. This is really a thought of my personal know-how of 25 years of implant industry. And the 3D printing in the future will be overtaking the milling, and so therefore we need materials which are stronger, which have more megapascals, which have the strength to be stable for final restorations and so on. But this is the developing what happens right now a lot. So there's a lot of materials in the market which can be printed, and you have to make sure that your printer is able to use the material you want to use. And there's printers, they can print 20, 30 different materials. Other printers can't print too many different materials. So this is important to take care before you make the choice of printing. Yeah. So Andrew is back.
Okay.
Oh, yep, yeah, I'm back. We see your screen. So continue, please. Very nice.
Okay,
so I shut up again. Sorry about that. And thank you for the questions, and we will answer more questions. Please continue.
Right. Okay. So workflow. We have a 1, 5, 2. Okay. So hard to see the fracture, but there's a split in that tooth. And to prove it, I've taken a photo of the extraction. Surgical guide, which is all planned in advance. Implant placement. And then in this case, we actually took a scan while the patient was in the chair. Designed this 3D printed provisional. If you can't design it yourself, there is that scan and smile service that you can make use of. You just have to book it in advance. Make sure that it's booked at a time that's convenient for everyone, and then basically take the intraoral scan, send it over. Within 20 minutes to half an hour, you'll get the file back. Very, very important, because when we 3D print anything, because of the certain tolerances and compensations that are inbuilt in our 3D printers, they do have certain parameters specific with regards to like screw channel diameters and slight adjustments in the design phase to compensate for any inaccuracies that some 3D printers can create. So very important that whoever's designing your temporary is aware that it is going to be for a tri-matrix implant, and it's going to be a 3D printed provisional. And then they'll use the right settings in either 3Shape or exocad. So this is 3D printed, polished. Once again, this is from Crown Tech. And then, of course, inserted. And that's basically what it looks like. Very clean, no mess. Patient leaves with a tooth. So, it's happy days. So another patient. This is Dominic. It's one of my favorite patients. 40-year-old male, fit and healthy, but his fracture is 2-1. And, is beyond salvage basically now. Okay. So once again, we're going to design and plan our case, this time in Blue Sky Plan. We're going to print the guide, do our osteotomy after extracting the tooth, and then, of course, we're going to place some sort of provisional. All right. Cool. So I'm using Blue Sky Plan in this case, not Excel Plan. A bit more of an affordable option, but here I'm merging the two data sets together. I mean, the software really does quite a good job already, but yeah. So it's an immediate case. So in order for us to actually create a guide, we actually have to digitally remove the tooth, which is basically what I'm doing here. I'm just sculpting the area that we want to remove from the model with a little brush. And then that's basically what it looks like. We're going to choose, in this case, the Tri-Matrix Pilot kit, because we don't have access to the fully guided kit yet. I mean, that will come. But for now, we're just using the pilot guide as per the Tri-Matrix, armamentarium. Placing our implant in this situation, I'm using what they call a multi-level implant. So it's not just a tissue level. Because of its concave profile, you can submerge it a little bit. So yeah, it's what they call a multi-level implant. And I use them anteriorly with great success. Marking our borders for our surgical guide. And then, bam, it's ready, okay? We're going to, of course, export that and print that out. And just basically what I'm doing here. Making sure that we choose the right files to export. And I think it works out to be around 20 euros to export one surgical guide. Printing on the SprintRay Pro 95S. And then out it comes. Crystal clear. We're washing it, curing it, and then we will autoclave it eventually. So Pro Wash, that's part of the SprintRay system. I'm a big fan of the SprintRay system because it's so easy to use and delegate. And I cure my surgical guides with the sleeve in, because just like with any resin, like our composite resins, there's always going to be a little bit of contraction when it's fully cured. So just so that you're not shoving that sleeve in after it's cured, I always, insert the sleeve in before it's fully cured. Just easier. Clinical day, piezo to help remove the tooth atraumatically, osteotomy with the help of that surgical guide. Now, I've temporized it temporarily because I did use actually the Scan and Smile service here. Right, so 3D printed temporary. This is 1 week after, and then insertion of that temporary. And this is actually the final scan. We're designing the actual proper restoration. This time I'm designing it myself. We're doing it in exocad. Of course, if you have access to 3Shape, you could do the same, but I like exocad. Marking the emergence profile, you can see how beautiful that emergence profile is. You can only really get that with a nice and quick temporary, just before the soft tissue collapses. It's a sign. And then basically that's looking good. And then you can spend, a lot of time on this. Of course, this is going to be for the definitive restoration. So we are going to spend a bit of time making sure that the shape is, as nice as it can be. I think I do go back and adjust that emergence profile a little bit. Of course, you can simply mill it out and print it out and polish it. But of course, I'm doing it in the software. I find it a bit easier for me to do. You can do as little as possible or as much as possible using the software. And as I said, if you don't want to have ExoCAD, if you don't want to, spend a lot of money on design software, you always have that option of that scan and smile service, which is very, very affordable, actually. Here I'm milling on the Craft 5X, which is manufactured by Doff, and I'm milling it out of Everest zirconia. So of course this is being dry milled. That's basically what it looks like when it's being dry milled. That's basically fully characterized. It's not a perfect result, as you'll see in a sec. Patient was happy though, and didn't really want to change anything. So you take your wins where you can get them. So if the patient's happy, then I'm happy. Well, could have been improved, yes, but it is what it is. And then because the patient's a Broxa, when on the day of insertion, we're actually going to design and print a night guard for the patient. This is AI designed on Medit software for free, and we're going to print it and actually issue it at the same day, all done in the one day. So that's the beauty of a system like the SprintRay system. It's fast, it's accurate, and it really opens up a lot of potential for same day or same appointment procedures. So once again, washing it in the same wash unit, because the beautiful thing about SprintRay resins is that they're all at least minimum class 1 certified to be in the mouth. And so you can mix or wash everything in the same container. Curing, and then I actually glaze it or candy coat it. And when we insert it, that's basically what it looks like. Didn't need to adjust anything with the bite. It was perfect. So yeah, that's Dominic's case. Yeah. And of course, you can see how beautiful that soft tissue profile is. Only possible, with a nice temporary solution. And this is your before and after. Good result. And let's see another patient. This is a 22-year-old female, indigo. She's medically fit and healthy. She's missing a lower right-hand side too. Because she's young, she goes out, she doesn't want to wear a denture. Asking a 22-year-old to wear a flipper like that, look, they're not going to comply. All right, so she wants a fixed option. So once again, we're going to design, print, try and then we're going to place. And this time, we're going to use our digital healing collar library. So this is basically I'm actually editing this healing collar library in Medit Design. Now you can use other software options out there, but I'm doing it myself. I'm just making the profile a little bit more concave. I just find that the soft tissue tends to creep a bit better into these areas, but you can just print it and adjust it however you wish. I'm just changing, the profile ever so slightly on the software, so that I don't need to adjust it so much in the chair while the patient's waiting. Of course, you can just simply print them all out in one go, and then polish them as you go. Nothing wrong with that, but I'm just showing you. Don't think that you're given this healing collar library. That's it. That's all you can use. You can do a lot of things. You're really just limited by your imagination. So once I'm happy with this, I will basically print all of these guys in the one hit. And that's the beautiful thing about 3D printing. You can print 3 of these, 10 of these, or even just one of these, the print time remains the same because the print time is all related to the actual total height of your print, rather than how many objects you have on your print bed, which is why we'll see in the future printing will very, very quickly become more popular than milling in certain applications because you can print something like this. We've got, I think, almost like more than 10 for sure, more than 12. I think it's about 12 or 13 healing collars right there, all printed at the same time. Okay. And then you can print them in advance, polish them in advance, and then that's it. Like there you go. You just on the day, you just pick up the ones that you want to use. So these are printed on onyx, and then I actually print these in zirconia as well. As I said, I don't tend to print healing collars in zirconia that much these days, unless it's like it's a slam dunk case, because it's very hard to adjust chair side, if not impossible. Implant surgery can be a stressful procedure already, and then you add on to adjusting zirconia, and we all know how difficult it is to drill zirconia. But I mean, it looks nice. In a nice, simple case like this, you get great soft tissue adaptation. It looks great. But yeah, these days I tend to get similar results, or if not the same type of results with printed resin rather than printed zirconia. But it's nice. I have a zirconia printer, so why not use it? So that's after it's fully polished. You can see how really nicely polished zirconia can become. So this is the case, missing 4/6. Then we're going to plan our surgical guide. Once again here, using Blue Sky Plan, using all the the implant library that Matrix has already been preloaded onto this particular software option. So that's super easy, no messing around. It's already there. So if you're starting out with the Matrix system, you don't want to spend thousands of euros or dollars on Exoplan, Exocad, 3Shape, then you can use cheap software like this. All right, so and that's what it looks like radiographically. That's what it looks like clinically. And let's look at our actual results. All right, so that's before, and that's after. No grafting, all right. No soft tissue augmentation, just the use of a semi-customized healing collar. I think, to be honest, that's a nice result. It's a good result, and it didn't really cost that much either. Before and after. Okay. And a nice case to slowly tie ourselves this presentation with. This is something that I worked with a technician. I call it almost like a window to the healing process. I thought, what can I do to actually see what's happening underneath? I'm curious. I'm a very curious person. I like to see what's happening, right? So I thought, why don't we actually make a provisional that allows us to see what's happening during the healing process? And this is what we did. Okay, so initial case situation on the left-hand side. You got a missing 1/4 upper right first premolar, and then we actually planned with my technician friend Jeroen from Dentique in Melbourne. We actually planned this case for the surgical guide and the printed provisional. I assembled it together, and then you can see it's polished really nicely. You can see underneath it, and this is at impression taking. That final photo on the right-hand side. No soft tissue augmentation, just a nice provisional, which you can see through. So this is the workflow. So you can see tooth is there, needs to be extracted. We've taken the tooth out, and then we're going to plan a surgical guide, this time in 3Shape. And we're also using that guide to create a provisional restoration. And this is it. So basically, your temporary abutment is printed out of a splint material, a hard splint material. I printed these on the Asiga Max UV using their ultra gloss tray, so there's very minimal polishing required. And then these veneers are actually printed out of Crown Tech. You bond them together with the Crown Tech, and then you polish them. There's no glaze. You cannot have any glaze subgingivally because it will cause inflammation. So these are just polished to a mirror shine using PMMA or composite polishing kits, and to finish things off with a cotton buff to really give that mirror-like finish.
Here's just a question, sorry.
Yeah,
I think
sure.
it's to this case. How many healing time is in this case? I think it was to the tissue healing just a slide before. How many?
I think I left this provisional for a couple of months.
Couple of months.
Yeah, about 8 weeks.
Because yeah, that I think the glazy clear material is very high biomaterial, biocompatible material.
Yeah.
And so
yeah, you can't. Yeah, exactly.
Going down until the tissue. Andrew, please you let's make it 3 minutes more to answer in some questions, and then we should close the presentation.
Okay, sure. To quickly talk about the cleaning process, printed restorations, you manually wash them. You try not to submerge your prints in alcohol because that actually damages the ceramic component. And so I actually manually hand wash these with micro brushes and a spray bottle with IPA. I actually also designed a little tool which you can actually assemble and print yourself. This is actually this particular tool, and there's a QR code to download it for free. Basically, it's 3 little parts, and then I'll just download it. But basically, it comes in 3 parts. You've got a container, put your prints in, little cap, and then another container with your IPA, and you screw everything together. Shake it like a martini shaker, and that prevents your resin from being completely submerged. And of course, as I mentioned before, the designer must use matrix-specific 3D printing parameters. Really, really important. You can't just use any one, which is why if you're getting people to design it, I would highly recommend the Scan and Smile service, because it's quick turnover and they're going to use the right parameters. And then with my patients, I actually call it a matrix patient pack. I actually print 2 temps, okay, and 1 surgical guide and 1 prosthetic screw for each patient. I print 2 temps because 1 will be placed on the day of insertion, and that will actually remain up until the day of impression taking, final impression taking. Now, on the day of final impression taking, I remove that temporary and I don't reinsert it back. I actually put the brand new, fully polished, completely autoclaved and clean second temporary back in. So there's no risk that you're introducing bacteria into that area. That healing site is always contacted with something that has been sanitized. And that really is the power of 3D printing, because you can print 2 of these for the same amount of time for very little material cost. So my MPP always consists of 2 temporary restorations, both polished and autoclaved, 1 surgical guide, and 1 prosthetic screw. That's my MPP, right? So yeah, but yeah, all in all, 3D printing, it's going to get better and better, faster, stronger materials are going to be out there in the market. Really, really looking forward to seeing what's going to hit our markets next year and the year after. I do apologize for all the technical issues that we had, but it is what it is. It always happens. It's the first time that's happened to me, but yeah, it is really an exciting time to get involved in 3D printing. And with the Matrix, these 2, Matrix and 3D printing really come hand in hand and really synergize really, really well. So if you do have any questions, these are my details. You can contact Holger, you can contact me. The photo that you can see in front, that's actually a Christmas wreath that I've designed using the ScanBridge files and the the digital healing collar libraries, and that's printed in filament. So yeah, just be creative. 3D printing is just a tool for you to manufacture something. As for what you manufacture, it's really up to your mind, right? Don't let yourself be constrained by just doing what is told. Okay.
Hey, thank you very much, Andrew, very much. And you see, there's a lot of hearts coming in, and we are still a lot of people listening to your presentation here. So it shows me that the interest for 3D printing is quite high, very high. which is really nice. And thank you for sharing your know-how. I think it's really, really a gift that we can work with you. And because at TRI, we are very clear that 3D printing is the future. The matrix is the implant which is ready for the future. As I explained in my part, you don't need to add any tie bases and so on. There was a lot of questions. I answered already a lot of questions during your presentation. From my point of view, there's just one question. How much there was one question I want to answer. The question was, how much is the cost for the scan and smile service of TRI? If you want to use the scan and smile service, it is for 1 crown around $20. So that means we design you for $20 in 20 minutes a crown. You can put it on your printer, and as Andrew's showing you, you can print in this moment, in between 15 minutes, you can print this crown for €1 cost of material, not even, because it takes maybe two milliliters to print this crown. And so your patient goes out with a temporary restoration on an implant based in less than an hour. This is something we only can do with a matrix implant system, where you do not need to add a tie base or create a model or something. This was a big question, which I wanted to repeat. What do you think about final restoration materials? Maybe Andrew, you know a little bit better. What do you think? Is there materials available where you can produce, for example, a full arch on for final restorations?
Yeah, so it's going to be really interesting how the next couple of years, or 2 to 5 years, turns out. There's a lot of research being developed in this type of thing. I think, of course, printed zirconia is one thing. I think the workflow currently for printed zirconia is quite a lot. It's not super easy, but it will get there. And as more attention is being put into printed zirconia, printed ceramics in general, I think we're going to find that a lot more of our larger restorations are going to be 3D printed. Then we're also going to be talking about different things that we're going to add to our resins to make them stronger. Graphene is one of them. It has been gaining a bit of popularity these days. When you add I think 0.2% or 0.3% graphene to resin, you actually make it more biocompatible and stronger. So that's one thing that is definitely something to keep an eye on. So all these different additives that are being added to resins, and everyone, all these companies are developing new resins every year. There's something new every year. They're looking nicer. They're getting stronger. So I think I get asked this question: will printing, overlap or printing supersede milling? I think printing will supersede milling at some point. That being said, I think milling is still a very great piece of technology to have at your disposal. There's always going to be a use for dental mills, for the next 10 to 20 years at least. But 3D printing really is going to be very, very hot over the next few years. It already is a booming
Okay, Andrew, I think we could talk, as you see, it's a big topic. We could talk for days about this topic. And I thank to the audience. We were a really crowded audience this time. Thank you very much for listening. Stay tuned. There's not another webinar in this year, but in the January, we will share with you the next webinar, which is going into 3D printing as well, and immediate chairside 3D printing of full arch restorations. So stay tuned with this. Last time I shared this QR code. There you can get all the information about the matrix system and also this scan and smile design service, which we talked about. Thank you very much, Andrew. I know it's late for you on the other side of the world. It's amazing how technique can work, if it works. And I think we managed the situation with your computer. Thank you very much, and have a Merry Christmas from Switzerland.
Yes, have a Merry Christmas to you all, and stay in touch, everyone.
Yeah, thank you. Bye-bye.